So I want to move on to a new topic this morning, although uh, a lot of the containerization material that we've looked at so far will raise its head here again, as you'll see. So the topic is CI/CD, and this is the lab that I want to walk through this week. I don't think I'll get through these slides this morning, and if I don't, then I will use the beginning of tomorrow morning's 3 hour session to complete these slides, and then I'll let you work on the lab. So let's work our way through these slides. So CI/CD for short, or the full label would be continuous integration slash continuous deployment. The D can stand for deployment or delivery. There is a difference between the two of them, and we'll see what it is in a while. And the context, I suppose, for all of this is you've got a team of developers working on a project. That team may not actually even be, it may be distributed kind of globally. They may not all be physically working on in the same premises, although that's not essential. But the general point is you've got a team of people, team of developers, and they're all busily working on the project, developing new features, fixing bugs. Now, uh, um, obviously, we kind of have to bring everybody's code together at some stage. And when do we do that? And the answer is, well, you do it continuously, almost on a daily basis, because people won't necessarily all have finished what they're working on at the end of the week or the end of the fortnight. It just doesn't work that way. So uh, this can actually be quite it's almost a management thing as to when we bring people's code into the larger project. Um, and obviously, when we add somebody's code, like when you're developing code, clearly you're testing it as you're developing it. You're doing that locally, though, on your local machine. And at some stage, your code is ready to be integrated with the entire application. Even though you may have a version of the application running on your local machine, it's still not the kind of central version of that application. So we need to bring people's code into the kind of central code base. And clearly, we would need to do a lot of testing after we've done that, even though you may have done some testing locally. You certainly would have done or should have done testing locally. But once you've integrated your code into the kind of final application or the current state of the final application, there needs to be a lot of testing done. That testing probably should be done, well, clearly can be done in the production environment, but it needs to be done in an environment that is as close as possible to the production environment. So all of this kind of activity is constantly happening throughout the lifetime, the development lifetime of a project. And so clearly that needs to be managed, otherwise it can be chaotic. And the kind of process or practice that we use to achieve this is what is referred to as CI/CD. Now, I'm showing you these two images. The image on the bottom is the image that I'm kind of showed you at the on week one. And it's an image that kind of describes DevOps as a process. And you'll notice that it's the exact same image that describes CI/CD as a process. And I think really the kind of history of it was that CI/CD is it's a newer term. Now, new as in it's been around for about 4 or 5 years, maybe. CI/CD as a term and as an idea has been around for slightly longer than that, but they are effectively the same thing. Although people would argue that DevOps puts a slightly stronger emphasis on what's kind of happening over here, whereas CI/CD was mainly focused on getting features out into the production version of an application as quickly as possible. Whereas DevOps has the same objective, but DevOps also talks about the importance of monitoring your application as it's being used in production to get some sense of whether it's performing well or not. So we won't go into that kind of stuff, but suffice it to say that CI/CD and DevOps do have a lot in common. So there's two parts, obviously, to CI/CD. The first part is continuous integration, and I'm giving you a definition. Probably the only time I'll give you definitions in this module, but I'm giving you, well, two definitions really of what CI is. And so just to kind of read through it, it's a software development, it's a practice. Now we will be using there are technologies that support this practice, but fundamentally it's kind of a practice that a software house uh, practices. And it's a practice where members of a team, a software development team, integrate their work, their code frequently. And frequently can mean, daily, potentially. So they integrate their code frequently, uh, will integrate it into the kind of the overall application, let's say. And this leads to multiple integrations per day. Now, when we talk about integrating your code into the final application or into the overall application, we're also implying that integration not only means just physically adding your code to the kind of central version of the application, but it also means running a lot of tests when you do that. And by the way, when you are developing code, and this is something that we might come to later on in this module, when you're developing code for your application, almost in parallel, you're also developing automated tests for whatever code you're developing. So they kind of come hand in hand. There's almost two streams of development that goes on. There's the application code and there is the testing code. You actually write your tests as code, and the testing code can be um, as kind of long as your application code. There can be as much testing code as there can be integration code if you do testing properly, of course. So anyway, back to CI. So CI means integrating your code into the overall application and running tests to make sure that your code doesn't break any other part of the application. And that's something that's constantly happening during the development period. And obviously, the objective is to identify any errors as quickly as possible. The as quickly as possible is very important as well. This is a slightly different definition. And why do we do this at all? Why do we do this constant integration and constantly testing during the development lifecycle? Well, we do it because we want to ensure the quality of our code. Okay, it's all about quality control. The how and the why then, how do we achieve continuous integration? Well, number one, you've got to have what we call a single source of truth. Or do I use source of truth there? I don't actually, it's a term. Okay, I'm giving you the technical side. You simply have a single repository, source code repository. And we were very familiar with source code repositories now. So in a sense, there is a single GitHub repo, if it's GitHub that you're using, it doesn't have to be though, which that GitHub repo is the repo that contains the current state of the application. And that's the one that everybody pushes to, if you like. You automate the building step of your application. Now, building could be anything really. If your application happens to be a Dockerized or a containerized application, then building involves, creating your Docker images. But lots of applications are not containerized. So building could be something like compiling your source code. Yeah, could be something as simple as that. Um, so you automate that. That's okay. That's straightforward enough. Everybody commits every day. I've kind of given that impression already. Um, yeah, that's okay. Not literally every day, but very frequently anyway. It's not a case of we always do our integration, at the end of the week or at the end of the month. It's far more frequent than that. Uh, when we talk about building the application, sure, we can do the build on our local machine, but it's important that we do the build on a kind of centralized server, and so that everybody can see that there is currently a build happening of the overall application. And everybody has kind of visibility of those centralized builds. So doing it you can call it a CI machine, but it's whatever it's called. It's some sort of centralized server. That's where the builds actually happen. Keep the builds fast, yeah, because there's going to be a lot of building going on. So it can't be something that takes an hour to complete. It has to be something that's very quick. Therefore, employing techniques like caching um, can be important if obviously when it's a very large application. Caching of any third party, like NPM packages, for example. You don't want to be downloading the NPM packages for every single build if your kind of package.json hasn't changed. And it rarely does really. Your package.json, if it's a node type application, your package.json tends to be created at the beginning of the project. Uh, and it doesn't rarely change during the project development. Test the application. Yeah, not just okay. I've mentioned about the importance of testing the application after every build, and we do a build after somebody commits to the repository. So there's that kind of sequence of committing. When somebody commits, a build is automatically triggered, and you run a test of the application. Now, where do you actually deploy the application to? I'm saying here you should deploy the application to a clone of the production environment. We often refer to that as the staging environment. So you deploy your application to a staging environment, and then you run the tests of your application when it's in that staging environment. And we'll come across that when we start to practice these things. Make it easy for everybody to, yeah, like it's very important that everybody can actually get the latest build of the application if they want to do some experimentation with it themselves. So, if it's a containerized application, there is a central Docker Hub repo, let's say, that everybody can actually pull down an image or images if it's multiple. Uh, um, can pull down the images of the application that were built most recently so that they have the most up-to-date version of it. Make the process transparent. I've kind of alluded to that already. Everybody will have access to both the CI machine, they will have access to the current working version of the application, if it's in some sort of Docker Hub environment, or it doesn't have to be if it's not containerized. And also everybody has access to the kind of the results of when a build was done. What was the outcome of that build? Did the build fail? Why did it fail? Some sort of statistics on that. So everybody can see that. The why we do all of this probably should be fairly obvious, I suppose. The why is we want to try and detect any bugs in our application as early as possible so that we can fix them as early as possible. Because bugs are really what cause cost overruns, schedule overruns, debugging them. So the sooner we identify bugs, the quicker we remove them, and the less costly they will be to the overall development budget if they are identified early. Increases project visibility. That's all right. Yeah, it's not only is it about identifying bugs early, but it's also about delivering new features to your customer base as quickly as possible. CI/CD and DevOps is all about getting new features as well as fixing bugs, um, getting new features out to the customer base as quickly as possible. Improve team, that's okay. Have greater availability. I've kind of mentioned that already. This is kind of saying, this slide is saying much the same thing, really. It's just a nice kind of catchphrase. It's all about better, faster, cheaper. That's uh, the kind of overarching objective of why we have CI/CD at all and CI/CD practices and automation of the CI/CD practices. Now, I've been talking about CI up to now. The CD part of CI/CD, um, it stands for continuous delivery, and it can also stand for continuous deployment. And they are different things, right? As you'll see when you read through this slide, continuous deployment is kind of an extension, if you like, of continuous delivery. But to distinguish between them, the idea with continuous delivery is that so after every continuous integration build and test, you now have assuming that the tests haven't failed, you now have a kind of a new version of the application. And that new version may have a new feature that wasn't in the previous version, or it may have a bug fix that wasn't in the previous version. So after every continuous integration cycle, if you like, you have a slightly newer version of the application. Now, the question is, do we make that version of the application available to our end users? In other words, do we deploy that version of the application into the production environment? And that decision is a kind of a manual decision. I guess project manager or somebody of that status, they decide whether we should actually release this version of the application into production. And if the answer is yes, then you kind of press a button and the deployment of that newer version of the application into the production environment, that's also going to be an automated task, but somebody has to trigger that manually, if you like, which is what kind of what I'm saying down here. So that's the idea with continuous delivery. You always have a new version of the application, but whether it gets deployed into production, that's a decision that has to be made by somebody, and that person or persons have to, as I say, kind of symbolically press the button to trigger the deployment of it. Continuous deployment, on the other hand, says that after every successful continuous integration build and test, the deployment into the production environment happens automatically. Now, clearly, as a software house, software houses that practice continuous deployment would have a very mature CI/CD practice in place. Okay, so but that is the difference between continuous delivery and continuous deployment. The how and the why, I don't think there's anything new here, really. New features. Uh, New features are uh, continuously integrated into the software. That's okay. We run an automated test. Sorry. Sorry. That's okay. Automatically deploy the application to a production-like environment. That's kind of the staging environment. I guess what I'm describing here really is, well, it's kind of somewhere between continuous delivery and continuous deployment. There's nothing new here on this slide, I don't think, really, when I look at it. Why do we do this? Reduce production deployment risks. It's okay. Change the version in production more rapidly. That's okay. Be able to release new. That's okay. I think they're all fairly obvious from what I've set up so far, so I don't need to go through them. This is just kind of a visual representation of the difference. I found it somewhere on the web, but the difference between continuous integration, continuous delivery, and continuous deployment. This is the continuous integration pipeline, as it's so we talk about these things as pipelines. Yeah. So again, just to quickly go through it, the first stage of continuous integration is the build stage. So somebody has done a commit to the central repository. That's going to trigger the automatic building of our application, whatever that involves, and that's completely dependent on the nature of the application. Assuming that the build is successful, build would also include maybe, or could also include uh, some static code analysis as well. Um, but if it's successful anyway, then we go through what the image is calling unit tests. Unit tests kind of implies that they are tests that are focused on the new feature that was added to your application and or the bug fix that has now been corrected in the application. So these tests here are only focused on, if you like, the new code that was added to the application. Because there isn't much point in following on this pipeline if at least the new feature uh, and or bug fix that has been added to the code base is causing problems. But if it isn't, if all of these unit tests pass, then we move on to deploying the application to our staging environment. And then we run a complete set of tests of this staged version of our application. And these again are automated tests. And these tests would include these tests, but would also include the unit tests that were created or developed by all of the other developers when they were developing their features. So clearly, these are, running the what we're calling acceptance testing could take quite a while for a very large application because you're going to have lots and lots and lots of tests. But and so that's it. That's continuous integration. If you want to have continuous delivery, then we add on this extra step. But the arrow I'm kind of trying to represent here, I think manual is written there. The step from here to here is a manual step. This step here is where we deploy it into production. Whereas here in the continuous deployment pipeline, the progression from acceptance testing to deployment into production is automatic. Once all of these tests pass, it automatically happens. Now, I guess I should say, right, that before this step in our pipeline, and of course, all of this is automated. It's not that somebody carries out all of these steps. They're all automated, and that's what we really are focused on in this part of the module. How do we automate all of this stuff? But before any of these pipelines begin their execution, so to the left, I suppose, if you like, somebody has committed code to the repository, but clearly that code needs to be reviewed by somebody more senior in the team. So it's assumed that that's kind of happening before these pipelines are triggered. And so, there has to be kind of a manual intervention before we start running these pipelines. So you may have heard of things like pull requests in GitHub, for example. So that whole kind of pull request procedure is happening here before any of these pipelines run. Uh, it's all well and good, I suppose, if we go back, it's all well and good having these continuous integration, if we just focus on this one, having these pipelines, but you know, if the build stage is frequently failing, then we need to really look at the automation of the build, or if any of these stages are frequently failing, then that's clearly not good. So what I'm saying on this slide here is it's very important that you maintain some sort of metrics on your CI pipeline, and that you track those metrics. And the idea of any metrics, of course, is that it, it will help you to identify whether whatever you're analyzing, which in this case is our CI pipeline, whether it's successful or not. And if not, how can we improve it? So I don't look at metrics necessarily in this part of the module, but I just think it's important for you to be aware of them. Some simple metrics might be of all, because we know now that the RCI pipeline is going to be triggered multiple times a week. And so simply keeping a track of how many times the build stage in our CI pipeline, how many times that fails, can be a measure of the success of our CI pipeline design, if you like. Or an alternative metric would be, okay, builds fail, but how quickly can we actually correct the failure? So the build repair rate, what's that like? The total number of, well, this is I mentioned, sorry, no, I mentioned that part of building might be to do some what's called static code analysis. There are tools that can look at just go down through your code and identify what are called static analysis errors. Simple things like uh, poor coding practice. Um, uh, and a simple example might be you've defined some variables, but you never use them in your code. So, it's not a bug as such, but it's just poor coding practice. So there are these static analysis tools that can identify those types of issues. And, you know, clearly you want to remove all of those before that code gets out into production. So maybe the builds are failing because our static analysis tools are always picking up weaknesses in the code. And that may simply mean that you need to um, provide some training for your developers. So that's what's being talked about here. Linting tools, they're also referred to as. Unit testing, line coverage, not going to look at that now, but going back to here, both the unit testing and the acceptance testing, there are ways of measuring how good the unit tests are and how good the acceptance tests are. A simple a simple measure is what's called line coverage. We might look at it later on. So that's what's being mentioned down here. Um, okay, so it's important to not just let the builds always happen, but also to keep an eye on them and see how successful is the build part of our CI pipeline, build and test part. So that's kind of the theory, right? What I would like to spend time on is just showing you a practical example of this, a practical kind of implementation of this CI/CD idea. And so there is a service or a platform called GitLab, um, which is a cloud service, I guess you'd call it. And we're going to use it. And there are lots of them out there, right? GitLab is just one of them. It's quite a popular one. both in industry. Um, so this is the one that we are going to use in this. GitHub as well has a CI/CD part to it. You may have heard of GitHub Actions somewhere along the line. GitHub Actions are really what we're on about here. But I'm going to look at GitLab instead. It's a richer platform really than GitHub. Um, but they're all quite similar actually when you look at the other, both GitHub and GitLab and the other alternatives that you may have come across. They all kind of do the same thing. Sorry, now I'm just checking. Okay, look at my watch. So what is GitLab? It's a hosted environment anyway, and okay, it's much more than CI/CD as it turns out. It's kind of what it's called. It's classified as a collaboration platform. Um, it's open source. There is a free version of it now. What you will be doing is creating an account for yourself on the GitHub, sorry, GitLab platform. Although as part of the registration process, you do need to actually provide a credit card, unfortunately. Now, there won't be any charging though, unless you abuse the service, of course, but I certainly won't be requiring you to incur any costs. But you do need to provide a credit card anyway as part of the registration process. You can run it on your own server machines, but we don't have access to that, unfortunately. And what I'm showing you here is kind of the full picture of what this GitLab platform provides. So at the center of it actually is just a Git repository. So this is a bit like GitHub, really. So there's lots of other um Git repository services out there. GitHub is certainly the one that most people use, but GitLab has its own Git repository. And so we will be pushing our code up to the GitLab repository, just using the exact same command, git push, except it's pointing at a different service. So that's fine. There's nothing new there. This is the part of the GitLab platform that we are going to be using. Well, this and both of them really. So there's the CI part now. It's both CI and CD as it turns out. But just to quickly scan over the other parts of the platform, because like I'm saying up here, it's much more than just a CI/CD platform. It's what's called a collaboration platform. So there's a part of the GitLab where that takes care of user management. So you can imagine if you've got a team of people working on a project and different members of the team may have different permissions. Some may only have access, read permission to the Git repository, and so on and so forth. So the whole user management side, um, GitLab provides support for all of that. Issue tracking, as bugs are identified and reported, we need to keep track of those. So that's what the issue tracker or, um, or the issue boards part of the GitLab platform deals with. Over here, this is kind of a project management, I suppose, and scheduling feature within GitLab. Over here, it actually, sorry, over here, it actually has its own container um, registry as well. So this is an alternative to Docker Hub. Um, I don't know what that's about. I'd say that's an old feature that isn't being used anymore. And the wiki part is for kind of project documentation. So it handles all aspects really of software development, project management. But as I said, we're only interested in these two parts here. I don't think I'm going to read over these fully integrated with. Oh yeah. So this is just talking about the sorry. This is just talking about the CI part of the platform. It's fully integrated with its own Git repository. That's hardly a surprise, but we'll see what I mean by that in a moment. And so, like when we talk about, if I just go back a couple of slides, we have these pipelines, but we have to describe these pipelines some way. And we describe them using code. Now, it's not procedural code. In our case, in the case of GitLab, we're going to be creating a YAML file. So we know what YAML is. It's a kind of a declarative language in a way. So we'll be describing the different parts of our pipeline in a YAML file. But that file is going to be part of our source code. It's going to be added to our source code. And therefore, and we're going to be committing our source code to the repository on GitLab. And so it's going to be subjected to version control, just like any other file in a project. And that's what's nice about it. So that's what I'm alluding to here. We have version control of the actual CI/CD scripts or pipeline. Git hooks we don't care about. Built on the, it is actually built on top of, and I will show you what I mean by this. The GitLab platform itself is actually built on top of a containerization idea. Uh, and as I said, I will make that very obvious to you as we work our way through it. So that's really why we looked at containerization at the very beginning, because everything is kind of dependent on that in this module anyway. Why? I think this is probably the same stuff as before. Application code and build. The build scripts is kind of a name for the that YAML file. Build has a kind of a broader meaning here than just the build stage. This is the unfortunate thing with our IT industry. We use the same terms sometimes for different things, but when you talk about the build scripts here, we're talking about, again, if I go back, we're really talking about the entire pipeline. Each of these stages has a build script associated with it. It's unfortunate that that terminology is reused. Um, Easy to get. Okay, well that's all right. It's certainly very scalable, although we won't necessarily be testing that. Isolated test environments, that's okay as well, I think. A bit general. Okay, so we want to be able to uh, describe a CI pipeline. We know now that it's going to be written, that description is going to be written in YAML. And in terms of uh, that YAML code, there are essentially three constructs that we talk about when we're describing uh, a pipeline. There is the pipeline itself, there are something called stages, and then there are jobs. So your CI process is what we call a pipeline. And that pipeline is broken up into stages, and a stage is broken up into jobs. That's the flow, if you like, or the architecture, if you like, of your CI pipeline. So pipelines consist of many stages. Stages consists of many jobs. Uh, okay. Uh, a pipeline is a group. A pipeline is okay. Yeah, a pipeline. So you could be considered a group of jobs that get executed in stages or batches. That's one way of looking at it. All jobs in a stage are executed in parallel. So you've got to make sure that that makes sense. Uh, if all jobs in a stage are successful, they run successfully, then uh, it moves on to the execution of the next stage in the pipeline. That's fairly obvious as well, I guess. However, if a job in a stage fails, then the entire pipeline execution is considered to have failed and it doesn't run any subsequent stages. And again, that's fairly obvious, I guess. These pipelines we define in a special YAML file, and the file has to be given this exact name, and this file has to be located in the base folder of your project. So when you do a git push to the repository, to the GitLab repository, the GitLab service itself looks for this file, and then it starts executing, if you like, this file. So it has to be named that. It's possible that you could give it another name, but you have to configure your kind of GitLab account to allow for that. But why would we need to do that? And once it has picked up that file, every time you do a git push to your repository, then it will automatically execute this file, if you like. And by execute, we now mean that it executes the pipeline that's defined inside in the file. And that may have changed from the previous execution. It doesn't really care about that. Uh, okay. So what does this file look like? And I could switch over to VS Code maybe for a few minutes. So let's supposing I've got some sort of software project here, which I don't really, but let's just suppose I had. So there's an SRC folder with lots of code in it, but in my case, because this is just a dummy project, I just have one file that doesn't have anything interesting in it. But here's my GitLab YAML file. And so when we look at that, what are we seeing here? And some of it is fairly obvious, given that this is a simple example. Okay, we can define just some variables, and these variables, like all variables in programming, we can refer to later on in this file. So that's fairly straightforward. Variables are just key value pairs. Um, Here is essentially kind of where we're defining the top level of our pipeline, as in we are defining the stages that make up our pipeline. And you can call the stages anything you want to. I've just given them generic names, but typically they would have names like build, um, uh, test, deploy, that kind of idea. But I've just called them generic names. Now, uh, you've got to be very careful with YAML. If you've written any YAML up to now, I don't know if you have or not, but um, you've got to be very careful with indentation and alignment in YAML. It's very sensitive to it, to those two aspects. Okay. Um, and YAML is just a cleaner form of JSON, as you know. And so JSON is all about key value pairs. So if you like, this is a key, and the value in this case is also some key value pairs. This is a key, and the value in this case, because they begin with that dash, the value is actually an array. So whenever you see dash at the beginning of a line, that means you're defining elements of an array. So the stages part of your pipeline will contain array entries. And even if there was only one stage, would be rare, but if there was only one stage in a pipeline, so let's say we took out all of these, what you cannot do is, okay, it's not an array, so I'll just do that instead. No, um, because GitLab expects this thing to be an array, even though there's only one entry in it in this case, you still have to use the kind of array syntax. And the array syntax in YAML, this is a YAML thing now, not a GitLab thing. The array syntax is that dash. But in our case, we have a number of entries, so go back to that. And you just name the stages here, nothing else. The rest of the file then is fleshing out the detail of each of the stages, but we do that by defining jobs. So everything from here on down, we're defining the different jobs that make up our pipeline. So we've got a job called job A, and we need to link this job to a stage. And it looks like from here, we're saying that this is linked to stage 1. I've commented out this line, but we'll come back to it. Then what we have is essentially, well, what's the script? Or what do we want to execute as part of this job? And you could think of these things here as the kind of commands that you would normally submit from the command line if you were doing this manually on your own machine, on your own laptop. Now, I'm not doing anything interesting here. I'm just doing some echoing, just using the echo command. But typically what you have here, as I said, are commands that you would normally issue from the command line, from the terminal prompt, in other words, if you were doing all of this stuff manually. Again, it's an array, and we refer to this now as the script associated with this job. And the same is happening here. Got another job. It's linked to stage 2. And this is its script. Again, nothing interesting happening in there. I've commented out bits which I'll come back to later on. Another job, same idea, and a fourth job. 2 jobs, job B and C, look like they're linked to the same stage. They're both part of stage 2. And job D is part of stage 3. And okay, I happen to have a stage that doesn't have any jobs. That's okay. It won't complain about that. So that's fine. Now, whenever I do a git push to my GitLab repository, and if I just do this, let's say, well, let's do it this way. I'm closely running out of time now, and that's okay. I didn't really expect to. This is I've just logged into my GitLab account. And if I go to some of my projects, which are here, and this is the one that I'm interested in right now. And so this is very kind of GitHub-like. We're looking now at the repository up on GitLab for this project. Yeah. And so what we're looking at right now there is if I go back to here, we're just looking at the Git repository up on GitLab. Now, if I go down to a different part of this GitLab environment, and if I select the build here, you can see that sorry, it's kind of sensitive. The build part is where you see all of your pipelines and jobs information. So if I mouse over pipelines, what you're seeing here now is past executions of my pipeline that I have triggered as a result of doing a git push to the repository. So these are actually pipeline executions that have already happened. And you remember my pipeline had three stages. So each of these represents the three stages. And because there's a tick mark, it looks like each of the stages executed successfully. And if I just click on any stage, clearly this is stage one. And if you're, well, you may not have taken it in, but stage one just had one job in it. This was it, job A. Whereas if I select stage two, it had jobs B and C. And if I want to see, well, what happened during the execution of any job, then again, select it. And if I click on it, what you're seeing here now is essentially the log of the execution of this particular job. And we had just two echo commands, yeah, in our script. And so you can see down here, here's one of the echo commands being executed, and here's the second one. Now, what's happening up here is the kind of setup that needed to happen in order for my job to execute. And I think I'll pick up the story there tomorrow. Effectively, what's happened here, right, is GitLab has started up a container and it has loaded a default image into that container. And then it executes these commands, my two echo commands, in the container. But I'm going to stop there today and I'm going to pick up the story tomorrow. So I will need quite a lot of tomorrow morning to finish off the slides. And I pretty much guessed that was going to happen anyway. So a lot of the tomorrow morning's 3 hour session will require me to spend a little bit more explaining on what's happening here behind the scenes. And then you'll be in a position to hopefully work through the lab. And essentially in the lab, what you will be doing is taking that multi-container application that you were working with in last week's lab, and you were doing it all locally. All of that now will be automated in a kind of CI process. That's the idea. Right, so I'm going to stop at this stage. I'll pause for questions just in case there are any questions. Maybe what you should do as preparation for tomorrow, if you go back to these slides here, the overview slides from week one, and if I fast forward to this one, and I mentioned down here all of the things that you need to install locally, and down here I mention various service accounts that you need to create for yourself, and one of them mentions GitLab. So if you simply take that link there and create an account for yourself on GitLab and have that ready to go for tomorrow. Right. Any questions before I wrap up? No? Okay. So I'll talk to you again tomorrow morning. Thanks. Bye-bye.